All right. Before, we talked about having a case where you use the law of sines, you get two possible sets of answers. When does that happen? And the answer to that, well, is less satisfying than I think you might want. When you're given two sides and an angle, that's the place to check. When you're given two sides and an angle to a triangle, you might get two sets of answers when solving the triangle. So let's take a look at an example. Here we go. Solve the triangle. A equals 3, B is 2, and alpha is 40. All right, let's do this. I'm given two sides and an angle. I might have two sets of answers. So first I draw a triangle. Does not matter what it looks like. I say this is 40 degrees. Alpha, that means A is across from it. B, say this is B. That means this will be beta, this is gamma, and this is C. I need to find those three things. Well, I first start with my law of sines. I can say sine of 40 over 3. That must equal one of the other ones. Do I know any of the other ones? I do, actually. I mistook something. B is 2. So I will change that. This is 2. And so then I'm going to try and find beta first. That's what I'm going to do. Sine of beta. So there we go. And now I will use the cross and multiply. Actually, I didn't need to cross multiply. I want this 3 over there. I want that to stay there because I want to get sine of beta all by itself. So if I did cross multiply, I would actually end up dividing by 3 anyway. So I'm just going to divide both sides by 3, I guess. So I end up with this. Now, I'm going to plug this into the calculator, and the whole reason why we might get two sets of answers is because we're using the inverse trig function. So here I would have sine of beta equals, well, maybe I'll just, I'll plug it into the calculator. So if I plug all of this into the calculator, I get 0.428525073124336. And I'm not going to write it all down because I'm done, all right? Get off my back. To find beta, though, I have to use arcsine. Anytime you're trying to find the angle, you use arcsine or arctangent or whatever trig function you have, you use the inverse of it. So it's the same thing as arc. And what I'm doing is, this is in my calculator right now, and then I'm just pushing second and then the arcsine button, and then everything's done, and then I get my answer. So I'm just a second. I'm doing it right now, you can't see, but it is sine inverse, which is arcsine, and I get 25.37. But here's the tricky part. Remember, this is going to be maybe possibly confusing. For arcsine, for inverse sine, that was restricted to negative pi over 2 all the way to pi over 2. Okay? So we plug this in and we get 25 degrees. Somewhere over here. However, this happens again. Sine equals this one other time, and it's over here, because sine is the y-coordinate. It's the distance from the x-axis to that point. So this happens again. How do we get the other angle? Whoops. Well, to get the other angle, you do 180 degrees, that's this, and you subtract this angle, and that angle is the same as that. Oh my goodness! So you would subtract 25.37. That means beta 2, so I'll write beta 2 is possibly 154.62 degrees. 63 if I round it. 63 degrees, okay. But notice this. This is the tricky part. Here we could go and get two sets of answers. But the trickiest part of this is if I add beta 2 to alpha, I get something that's bigger than 180. I get 194 degrees, and that's bigger than any triangle has. So actually, beta 2 is too big in this particular problem. So we only have one set of answers. So we can just continue on solving for the rest. So you only get one set of answers, and you can continue on, continue from there. I'm not going to do it. It'll take too long. Okay, so what about a problem that does have two angles for sure? What would happen? Well, you would get beta 1, and you would also get beta 2, and you would check it with the existing angle, and if they both add up to something that's less than 180 degrees, then they're both valid answers. So it could happen twice. Or so you get two sets of answers. I'm going to write that down. So here, if both beta 1 and beta 2 added with the given angle, that was me, the given angle in this case was alpha. That was me checking to see if it added properly. So if you check alpha or beta 1 and beta 2 and they both work, they both give you something that's less than 180. They give you, like we added with 40 and got 190 something, and that doesn't work for triangles because triangles can only have 180 degrees, exactly 180 degrees for all their sum of their angles. So if beta 1 and beta 2 added with the existing angle and was less than 180, that's when you would get two sets of answers. And so what you would do is pretend like this was one set, and then you'd find gamma 1, you would find gamma with using this beta, and you'd find the C value using this beta and that. If you had two sets of betas, then you would stop this part and then find gamma using this beta, and then find C using this beta, and then you'd have your two sets of answers. I hope that makes sense. We'll be done with this video right now. If you don't understand it, you should look back at this part 2 of that last video. That shows going through the whole entire thing. But when you have, the moral of this story is when you have two sides and an angle, you might get two sets of answers. When do you get two sets of answers? When beta adds with the existing angle is less than 180, and when beta 2 adds to the existing angle and also is less than 180. If beta 2 isn't working out, then you only have one set of answers. We'll be done. Goodbye. Have a good weekend. Or maybe you had one because you're watching this. All right.